So we're going to stay in those ionic compounds with the type 2. So the type 2 are still between a metal and a non-metal, but this time we're going to take a look at those elements here that have multiple valences or multiple combining capacities or multiple common ions formed. So if you look at the periodic table and you see your cation, your metal, has more than one combining capacity, then you're going to be using this type 2 naming system. And in that type 2 naming system, you basically have two different ways. So you can do it with the Roman numeral system, which is kind of the stock naming system. It's the classic way where you just list the common ion behind. So iron could be +2 or +3. And so in naming the compound, you spell out which combining capacity, which ion is actually being used in that compound. So in this, it's very similar. So it's still that first, the cation name, and then the anion root name and the ide. So it's really just different with this number specifying which charged ion you've actually used in that compound. There is an older system where it basically takes that root name in Latin. So we talked about this when we talked about the different weird symbols for the different elements. And it ends in an ic for the higher combining capacity and an us for the lower combining capacity. So it might be ferric oxide or ferrous oxide. And so in these ones, the way I remember it is that it would be icky to be, highfalutin, have lots of money. I wouldn't want that. Us, like us, me, is lower, right? I don't have as much money as the fancy people. So terrible memory device. Usually I only save that for like in person, but I've put it in the videos here to help you out. It's certainly not written in the notes. So naming these chemical formula, let's go this way. So we have copper 1. So that means that copper, if I look at the periodic table, could have a +1 or a +2 charge. But this has specified with the Roman numeral that I'm using the +1 charge. And oxide means oxygen is my anion. And so combining these ones, I would have to have 2 copper atoms for each oxygen atom. And so copper 1 oxide would look like that as the formula. Lead 4 phosphide, so that means it's Pb, and it specifies that I'm using the +4 ion, and phosphorus is always -3. And if I crisscross these ones up, I would have Pb3 P4. That would be the formula for lead 4 phosphide. Gold 3 nitride, that'd be Au +3, and nitrogen is always -3. So combining these ones up, and just to reiterate, I'm not memorizing these, I'm working off my key, but take the time and find them on the periodic table, right? That's where I'm pulling those from. So combining these, electric neutrality, I would have AuN as my compound. It's a 1-to-1 ratio here to make this electrically neutral. So these ones down here are the Latin system. And so remember the ic was higher and the us was the lower of the combining capacities of the common ion formed. So I need to be able to know what my options are. So for this one, cupric, I'm going to use the higher. So it's either +1 or +2, but I would use the +2 combining capacity because that's what this is telling me. Ic is the higher. Chlorine is always -1. So combining these to an electrically neutral compound gives the formula of CuCl2. Cuprous iodine, so cuprous would be Cu, and the us indicates that I'm using the +1 combining capacity, the lower of the numbers. Iodine, always -1, and electrically neutral compound, crisscrossing them up, Cui. Plumbous oxide means that it would be lead, and lead has the options of either being +2 or +3. Oh, I can't do it off the top of my head. See, I told you I don't have these memorized. Where's lead? Oh dear. Lead, 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 lead. PB, where are you? Somebody's finding it faster than me. Did I not write that down? Oh, +2 or +4, but I'm still not found it on the periodic table. Okay, let's go back because I found it in another resource. +2 or +4, and the us is the lower. So that's +2, and oxygen is -2. And so making this electrically neutral, I'd have PbO as my formula. Sometimes students have a better time going one way than the other. So this time we're going to take the formulas and we're going to come up with the names. And so we're going to use the Roman numeral system, that stock naming system. So this would be iron and nitride. And I'm going to put in Roman numerals the combining capacity of the iron. So I like to show a bit of my work. So iron is either +2 or +3, and nitrogen is always -2. So how did I make this electrically neutral? Well, I crisscrossed them up. It was the +3, and so that would have me put 3 in there for my name of the compound. Let's take a look at the next one, SNS2. So that's tin, right? So SN, and I could look it up on the periodic table. I've done this in advance to save you my blundering. So it would either be +2 or +3. Sulfur is always -2. So in coming up with these ones and putting them together in this electric neutrality, oh, sorry, +2 or +4 for tin. Sorry about that. So in putting these into electric neutrality, I didn't use the +2, I used the +4, right? That would be a 4 and that would be a 2. If I were to crisscross them up, it's a 2-to-1 or 2-to-1 ratio here to make them electrically neutral. So that's what I spell out. This would be tin 4 sulfide. You can use an F or a pH in the word sulfide. I tend to use an F, except for on rare occasions when I feel like using a pH. Let's keep going on these. So we'd have iron, and iron can be +2 or it could be +3, and nitrogen is always -2. So putting these together, kind of working backwards to figure out how did this get made, it wasn't the +3 combining capacity that was used. So I'd spell it out as iron 2 nitride. Let's try the Latin names for these ones. So it's either ferric or ferrous, and I have to sleuth to figure out which one it is. So it could be Fe +2 or +3. Sulfur always has a combining capacity of -2. And so in this, if I were to take a look at which one was used, well, it was this one that was used, right? So that would be the lower. So that would be the ferrous sulfide, not sulfide. My pen is pulling things together. So ferrous sulfide. In your formula pages, you do have these root words. So maybe I can find it for you. Right here, where is it? Here. So this table 3, that can be really useful because you don't have to have it memorized. So that is a great resource to remember. The other thing you might want to add is if you're a little bit rusty on your Roman numerals, you know, they go 1, 2, 3, 4, 5, right? Just to remind yourself of what those are. So let's go back to the notes. The last two, we'd have PB and O2. So PB can be either +2 or +4, and oxygen is always -2. Sometimes I write them as -2 and sometimes as 2-. I try to be consistent in the notes, but I'm pretty sure I flubbed up a few times here. So putting these together, I didn't use the +2 combining capacity because I wouldn't have this 2-to-1 ratio. And so I used the higher, so that would be icky. That would be the plumbic oxide, which is sort of a weird word. but hopefully we're unraveling the mysteries behind this Latin naming system. It is an older system. The stock naming system is usually a lot more common these days, but I think it is worthwhile just for your literacy and nomenclature to figure this out. So tin, looking at the periodic table, it's either a +2 or a +4. Look at me backwards here. And then sulfur is always -2. So in figuring out which one was used, it was not the 2, it was the 4. And so that would be Stan us sulfide. Oh, that looped again there, sulfide. So we've done the type 1s, we've done the type 2s. Up next are the type 3s, which are different than what we've been doing. So far we've done ionic compounds between metals and nonmetals. Type 1s being metals with only one combining capacity. Type 2 being these ones where you had options and you had to figure it out and name it accordingly. Type 3, we're going to go back into covalent compounds, so stuff from beyond the step, or nonmetals. So when I take a look at type 3, these are compounds between two nonmetals. And so they are typically covalent bonded. Examples that you know are carbon dioxide and carbon monoxide, right? In these, the way you do it is you're going to give a prefix that corresponds to how many atoms are present in the molecule. And so in the compound, it is also a molecule, but that's okay. So in the prefix, unless it's 1, so I don't say monocarbon dioxide, I just say carbon dioxide. And always on the second, you add in that prefix. So this is carbon monoxide. So always on the second, always the prefix. On the first one, the prefix, unless it's a mono. So let's try some of these. These ones usually work pretty well. And again, the prefixes are listed over here. I'm pretty sure they're also in your formula pages up here to double check with this stuff. Okay, so let's do some of these examples. We want to go from the name to the formula. Carbon disulfide. These ones are pretty literal. In these ones, I'm not going to talk about combining capacity because this is covalent bonding. This is sharing of electrons, and it doesn't work as easily as writing out those +2s and +3s, like showing that rough work. It's really just a literal translation. So sulfur trioxide, there's the formula. Diphosphorus, this is the first one that's more than 1. So these ones didn't have the mono on them. So diphosphorus pentoxide. And you drop the A's if your last one starts with a vowel. Usually you do a few of these and then they just start to sound weird, but there are a set of rules or conventions behind them. Going the other way, we're going to name these. So in order to know which system you're naming, you might want to locate them on the periodic table. Remember, these are all from beyond the step. These are all non-metals. So always when you're learning these things and they're nice and neatly separated out by the different, headers, like you're naming all type 3s, they're pretty straightforward to do. It's when they get all jumbled together and you have to pull apart the different naming systems and know when to apply each rule. That's really my goal with the bingo activity that we have. So this is nitrogen dioxide. This one would be dinitrogen monoxide. Dropped the A because my second element starts with a vowel, and I put the mon in here, even though when it's at the beginning and there's just one, you don't put it in there. So this would be nitrogen trifluoride. This would be dinitrogen tetrachloride. This one we know is water, but using this naming system, it would be dihydrogen monoxide. Technically water, is appropriate too, but using our words with these systems, I would name it dihydrogen monoxide. I don't think I would order that because nobody would know what you're talking about. And this last one, sulfur hexafluoride. Oops, that was sulfur. I got carried away thinking about the pHs and the Fs. It seems to be it's a British and an American difference, but I tend to go with the Fs for some reason. So that completes our type 2 and type 3 naming systems. We're going to come back and in the next video we'll do polyatomic compounds and our acids.